So I just want to let Daniel tell us a little about what ShopKeep does, and yeah, here you go.
So I'll be super brief because I'm sure you guys didn't come here to hear me talk. ShopKeep, we make an iPad-based point of sale system for very small merchants. So talking in the 1 to 3 location kind of merchants, very, very local business. As you can see by our sign, Take Back Main Street is what we're trying to do. Help the really small merchants compete against much larger companies that have a lot more technology that they can bring to bear. And so we make an iPad-based point of sale system that really helps them optimize their business, and then it brings it all up into the cloud where they can do a significant amount of reporting. We've got about 24,000 locations that use our product today, and to put that in perspective, there's about 11,000 Starbucks in the country, so that's more than twice as many as there are Starbucks. Everywhere you look, there's a Starbucks. It means everywhere you look, there's one of our customers. They just don't have the sign in the door. Anyway, let me hand it over to Jesse. We do use Docker very heavily in our platform as a service, and we are hiring. Thanks.
Great. Hopefully we can get you guys to speak then soon. Keep plugging the speakers. Awesome. And Daniel has the distinction of being a 2-time DockerNYC sponsor at 2 different companies, so that he's in a very small group of cool people. Next up, Alex Dubovoy of Averity. Thanks for the sponsorship. Tell us a little bit about...
Hey guys. My name's Alex Dubovoy. I manage the DevOps team at Averity. I am the guy who's been sending you all those LinkedIn requests. So I know most of your faces, but thank you very much for coming. I wanted to thank all the great folks at Contino. I wanted to thank Daniel for this amazing office space, and to Shawn, Ian, guys, thank you so much for taking the time to speak, and also thanks to all of you guys. This community is really special. I really enjoy working in the DevOps space a lot. And I chose to work in this space because I really feel that the engineers are a lot of fun, very, very real. And those are the kind of people that we employ at Averity. Those are the kinds of people that we enjoy doing business with. I'll save my sales spiel for another day. And I hope you guys will hit me back up whenever I do reach out. But thanks for coming, and have a great time.
Awesome. Thanks, Alex. So just a few orders of business. We always provide some time in the beginning for announcements. Any conferences or other meetups you want to tell us about, or birthdays, we'll sing you happy birthday. Anyone have an announcement they'd like to make before we get started?
If you need a job, call Averity.
Jobs at Averity and ShopKeep. Contino also, I'm sure. Thanks to Nina also and Destiny, if you're listening on the recording of the future. They were indispensable at making this all happen as well. So last call for any announcements or conferences. Nope? All right. So how many first-time DockerNYC visitors today? Awesome. And how many Docker users of any sort? Have you ever used Docker? All right. How many people are using Docker in a production setting or a client-facing setting? Okay, nice spread. All right, so I'm just going to hand this off to our first speaker here from the New York Times to tell us a little bit about how he's leveraging Docker in his CI/CD systems. Shawn Bower, great speaker. Got to spend some time with him today, this year at Velocity, so definitely listen up. He's got some good information for you.
Put on the stand. Do you want it in the stand? The game's not that strong. Oh, mostly demos, so it's going to be hard to hold the mic in. We'll work it out. Okay. Nice, it's loading. All right, I'm going to try to talk as close to the thing as possible. I'm going to do a bunch of demos probably. So if you can't hear me, I guess raise your hand or scream at me. How many of you here have used Swarm? It's free, right? It's good stuff. I got a mic guy. This is exciting. Okay, so we're going to talk about who I am, which is super boring, mostly a hack. Talk about what the problem is we're looking at. Mostly we're going to talk about load testing. Who likes load testing? Come on, guys. It's exciting. All right. We're going to talk about all the sweet things you can do, like with nothing more than like downloading images off Docker Hub, which is pretty exciting. We're going to ramp it up, move it to Compose, and see what we can do by, having a swarm instead of just like one Docker node. What can we do by throwing many containers at a bunch of nodes? And then I'll answer questions. So who am I? I'm a Docker captain. If you guys don't know what that means, there's a couple of us in the New York City area. Jesse's one of them too. We have written a bunch of blog posts. We talk at conferences, and generally are part of the Docker community, working on the open source Docker projects, working with Moby, working with the folks at Docker to kind of get the word out about Docker and all the good stuff that it can do. Up until 5 months ago, I was the cloud architect at Cornell University. We were a very early adopter of Docker. Literally, like the first GA release, we were on that, and because I am an incredibly crazy person, we went live in production, I think, on 1.7 of Docker, so a very old version. My job primarily there was to help us move to the AWS cloud. The CTO went to a couple conferences and got the whole "we must get out of our data center" speech, and then came back and told us. So we got to work on figuring out how to actually do that. And Docker was a big part of that for us. For us, we were focused on not reproducing the mistakes of the past, not having all these pets that were hand done that we couldn't reproduce, that we couldn't patch, but to really move to infrastructure as code and then move it to the cloud. So 5 months ago, I left to come to the New York Times as a senior site reliability engineer. Oddly, I'm working on the data center evacuation yet again. So the Times has also heard that pitch. We're moving all of our stuff out of our on-premise data centers to Google Cloud and Amazon. And I work on a team that is kind of the glue for that. We work with all the other teams as they, that's my clock, as they move their stuff to the cloud. And we provide a lot of tooling, Terraform, Vault, Console. There may be a theme you guys can sense there, if you're familiar with those tools. All right, so the problem, load testing is for winning. So we have all these great things that we've done in the data center, and we want to move into the cloud, but our management is scared to do anything with the least amount of risk. Does that sound familiar? Yeah, okay. So what do we have to do but constantly prove to our management that what we're doing will be okay, it'll work the same or better as it does now. So a big component of our move to the cloud was load testing. Load testing on-premise, load testing our infrastructure in the cloud, making sure that we could see similar results. At first we did this with a lot of, there's a lot of great hosted options for this, right? So, and disclaimer to this whole talk, I'm not suggesting you do what I'm doing. It's actually pretty cheap to go out and get Blazmeter, Sauce Labs, Browser Mob, and do this with a hosted solution. So if you're doing that, great. But we looked around and we're like, wait a minute, we bought into Docker, we bought into clusters. They're not 100% utilized. What can we do with all the extra capacity? And so that was when I kind of thought about this concept of, for years, we've been using things like Selenium and X-virtualized frame buffer and running all these tests. And honestly, that's what these companies like Sauce Labs and Blazmeter are doing for you, right? You're writing a little script, they're creating some Selenium grid, they're throwing load at it. So, why not just do that, right? So who's familiar with Selenium Hub here? Yeah, fair amount of people, right? So pretty old concept. You got the ability to write these little scripts. Started out as a Firefox plugin, right? Supported by Java in the back end. You can write code to kind of control a browser. Firefox and Chrome are the two normal options. But Selenium also provides, if you didn't know, a really cool hub and spoke model. So you can use their Selenium Grid product. You can go download it. You run the hub. You get a bunch of nodes to register to it. You send all your workloads at the hub, and the hub distributes that work to the different nodes. So again, this seemed like something where Docker would be a big win, right? If we can create these nice little containers, we can throw this all at a cluster, use all the extra capacity that we're not using to do our load tests, save all that sweet Blazmeter money, and buy 30 pizzas or whatever we got out there. So for what we're doing today, I'm writing a really simple Selenium script. And because I'm not even remotely vain, I'm just going to like continually query Google for my own name. I figure that's the best way to do this. All this stuff, I have a repository with this stuff if you're interested at the end. So we got the script. We love Selenium. We already figured that out. But like I said, one of the things I love about Docker is how much work is already done for you. So if you go out there on GitHub, if you go out there on Docker Hub, you'll find out the good folks at Selenium have already provided you with all the magic you need. You got containers for the various nodes, Firefox, Chrome, and in fact, they provide you with debug versions that have VNC pre-installed. So if you really want to like be a voyeur and watch your browsers go, you can do that as well. So let's see what we can do with a very just grabbing a couple of containers. So I'm going to go ahead and make that readable. Is that readable? Yeah. Cool. Did everyone get my password? So again, we can just, we can grab this first command here, and all this does is grab from Docker Hub the Selenium hub image. Zoom in. Oh. Better? Yep. Is that better? Cool. All right, cool. So now we got our Selenium hub running. So I'm going to go and grab us a Firefox node. Run that. Nothing more exciting than watching things download. Cool. So we're up and we're ready for traffic. Let's see. So someone told me not to do a live demo. What's that? Yeah, sorry. Yeah, I should have done it on both windows here, huh? All right, well, we'll skip this one because apparently I didn't install the right version of Ruby on my server here. But the idea is here is like once I've got this up and running with nothing more than grabbing these images from the hub, I can start running load against it. So we'll just pretend that that worked. So it's not a very useful test to have just one hub, one node running. So what we want to do is start moving this to Docker Compose, and then be able to move this to a cluster, right? So if you're familiar with Swarm, this will look pretty basic stuff here. We're going to create a couple of services. The first is our hub service. It's going to listen on port 444. We'll create a Firefox node. It's going to, this command is not used anymore, but I left it in here to kind of display what it does. It allows you to link that Firefox node directly to the hub. And part of this process is it creates a network for us. So it creates this overlay network that the containers can talk on with each other. And so it's important to make this network attachable. So what we'll do is we'll be able to put this up. We'll be able to scale the number of nodes we want. And then we'll be able to attach to it and run our script. All right. So hopefully the part that I practiced a bunch of times goes better. So if you haven't seen this before, Docker stack deploy allows us to take that compose file and deploy that to our swarm. We can then run a services ls command. We'll see that we have the two nodes that we had in that compose file that we just talked about. So we have our hub and our Firefox node. So we have one of each. So now we should be able to look at the logs of either of those containers. In this case, let's look at the hub. So I can see that the hub started up. I can see that it started up on 10.0.0.3, and that one node is already registered on 5. So that seems good so far. So I should be able to I'll try to make this bigger as well. So now I should be able to run my container that has my load test script in it. So luckily, I got the same IP address as I did the last time I ran this. So there's two ways we can run this, and this is not the way I want to run it the first time. So we can actually see it run. I'll use the docker run command. This will let us watch it as it runs interactively. So there's a couple things that is important to this. We have to pass it that IP address so it knows which hub to talk to on the 10-space network. And then if you haven't seen it before, the -- network command, that's going to allow us to attach to that fake overlay network we've created, our virtual network. So if this actually works, we should see stuff start happening over here. Which is good. And you can see we're getting a very slow response of finding my name on the internet, which is exciting for me at least. You gotta push my name up that list. So what's the problem here? Why is it so slow? I got one node, right? So I got one actual browser taking actual browser time to click through these events. It's very, very slow process. So as you can see, it's taking very long to find my name a bunch of times. So what I should be able to do is just scale up my cluster. Let's do 20. And if you guys haven't used Swarm before, this is one thing I'm really excited about with Swarm is that it's very quick. So that's how long it took me to launch 20 new Firefox browsers. If you ever launched Firefox, that's pretty impressive. I can't get to do that on my machine. So again, oops. Oh, sorry, okay. Can't run the Same container, same name. So the way the script works is it launches a bunch of threads, and those threads each loop through like searching my name. So the first hit that comes back usually takes a few seconds. But we should be able to look at the log files of the hub machine again, and it's going much faster. And we see the results coming back. The first couple will be slow, but then we're going to see it start to really kick back because it's waiting on a thread join. But you can already tell that it's going much faster than it did last time. And all I had to do was like one run command and scale up that. So this still isn't ideally what we want to do, right? Because I'm not really like utilizing all 20 nodes. Like, so what's the problem now? So now the problem is like I only have one load driver, right? So I'm running that one container by itself to kind of like run the load against that machine. So we're really not utilizing all 20 Firefox browsers. We're just doing as much as we can put work in the queue. So if we want, we can start putting these in. We can actually run this as a service as well. So the command here is basically the same. So last time I ran docker run. This time I'm going to use a docker service create. When I do a service ls, we should see if I can type. We should see our new test runner, and we should see, a small amount of activity. And then, oops. It's possible that I have now killed my cluster. So, okay, it's going. So you can see we're clicking like much faster now than we were before. So conceptually, the idea here is you can easily deploy a service of Firefox browsers, and you can also deploy another service of load drivers, and use that to mimic actual users. Like a lot of companies will call this real browser testing, right? Because we're actually using the browser to drive the traffic rather than using some curl script, right? And the advantage here is that like real browser users don't run commands instantaneously, right? They click on buttons, they wait for time, they wait for pages to load, and this allows us to actually simulate real traffic. So. And I'll take questions. I mean, that.
After you run all this stuff, how are you aggregating it to a port or something, or are you running it through Jenkins, or how exactly are you going about the automating this thing? I assume no one's typing this thing.
We have one person that just types this all day, all day long. No, definitely we're using CI/CD pipeline. At the times we use Drone. Anyone here familiar with Drone? Cool. So since this is a Docker meetup, this is a pretty useful tool, in my opinion. Drone is a container-first CI/CD platform. Everything you do in your pipeline is actually an image and the commands you want to do inside that image. There are some pre-built plugins that will do things like push to Docker, push to GCR, push to Kubernetes, that sort of thing. But it's truly like Docker native. So if you're working with Docker, it is super handy. So you can find that at drone.io if you're interested. But yes, we use it in our CI/CD pipeline. This is all automated. In fact, we often use Kubernetes at the time, so you can do the same thing here. It's a little bit harder to demo, and the YAML files are grosser, so I just stuck with Swarm. Anyone else? No? Okay. Oh.
Thank you. This is about one of your earlier slides. You were mentioning that using vaults for,
yes,
I assume, configuration management?
Well, I can't tell you what I'm using Vault for. That would defeat the purpose. Yeah.
Could you talk about that a little more? How you use it? How, like, in what extent?
Sure, I'll get into that a little bit. And this is something that a colleague of mine at the Times want to come and do a whole topic on. I'm running the team that's responsible for our Vault deployment. What we're doing is trying to consolidate secret management across the entire company. You guys are probably familiar with the crap show that is secrets. We got a bunch of stuff that ends up in GitHub repositories, a bunch of things that are on people's desks. Sometimes people GPG encrypt, sometimes not. It's kind of a mess. So we've started using Vault, and Vault is fantastic and terrible all at once, like everything in IT. It's really good at security, but it is a total blank canvas. It's like you get this really secure place to put stuff with a C prompt and like no directory structure, no nothing. So we actually have spent a lot of time developing a tool we call Goblin that uses Terraform to actually manage the configuration of Vault. We've introduced the concept of namespaces within Vault. So we can take typically a GitHub repository and map a very similar namespace into Vault. And so we can have the secrets matched up to the application. And we use the GitHub teams and organizations to control the flow of who can manage those secrets, right? So Vault has a GitHub authentication provider. We just tap into that. You log in with the personal access token. Then we go find out what teams you're on. Then you get the policies that allow you to look at the right stuff in Vault. I also have written what I call the Vault GKE shim. It's a very small init container. For those of you who use Kubernetes, you may be familiar with the fact that you can have a specific type of container called an init container that only runs and then dies like at the beginning of your process before the rest of your containers boot. And what that container does is it wakes up, uses the instance metadata provided by Google to get a signed JWT token. I know I'm going through this super quick, so you guys can grab me afterwards if you want to hear more. Gets you a signed JWT. It then takes that and authenticates you to Vault, and then you give that shim a path or a comma delimited set of secrets that you want to get out, and it creates a shared memory volume, writes to the shared memory volume. Your containers wake up, read from that shared memory volume, and therefore you're not writing to disk, and you're not leaking through environment variables. So I don't know if that answered your question. Or? Yeah. Cool.
Which meetup will your friend talk about this?
Probably this one. I brought the wrong topic, huh?
Yeah, for simulating traffic, how much would come up as valid traffic in like any analytics tracker?
In the case of what we're doing, all of that traffic will come up as valid. And that's the good part about using something like Selenium, because you're using a real browser with a real UA. And it's going to come up and look like real traffic as opposed to like, like Apache Bench or something where you're just going to slam it with a request. Yeah. Yeah.
Is Goblin open source?
It is going to be open sourced. Stay tuned.
You mentioned you're on a project to move apps into AWS. Can you talk a little bit about how do you, I'm sure there's a lot of legacy apps that are not very friendly. How do you go about prioritizing what you move towards, and how do you go about converting apps?
Can you repeat the question? Oh, sure.
So I heard he's helping move the applications in NYT from like local data centers into AWS and Google. So if you can talk a little about how do you prioritize what apps are more easy to move versus legacy app, which might not be very cloud friendly.
I think that I might be the right person for this question. So within the Docker space, I've been known as the dude that containerizes all the legacy junk. So I've written 3 blog posts on docker.com about legacy and how I actually don't believe that like there's a wrong thing to containerize. I think the thing is to look at it as Docker is one of the many tools you have to achieve infrastructure as code, right? So even if this legacy application is really just a long Docker file that used to be a bash script, you now have that in a code repository and you can repeat that process, right? So one of the first things that we did at the university was actually a legacy Confluence application. Who loves Atlassian? Yeah, not really. So it was, a very legacy-esque J2E, Tomcat, the whole nine application. And I would not throw that at a Kubernetes cluster because that would be terrible. But containerizing it still was a big win for us because we could actually reproduce the process to make that container and to deploy it. And we could patch it much easier. It became as easy as changing an environment variable in our Docker file, and all of a sudden we had a patched version. The way we would do that was we would use Cloud Init or whatever to at boot time grab that container, pull it down, mount a volume of disk space, usually EFS, or we started out with a shared NFS volume. Because again, most legacy apps have all their state in some god-awful NFS share, right? So we'd mount those containers and run those, and we'd run them just like we always did. We'd run them with auto-scaling groups, we'd run them with clusters, the Tomcats would actually talk to each other. We just had them in containers because it made it much easier to deploy, right? So honestly, when people ask me what should I deploy first or what should I containerize first, I always say your legacy apps. One, you know them way better than any of your other apps, right? Like, you know all the garbage that thing does and what's going to bite you, right? And two, the benefits of doing it are huge because those legacy apps tend to be things that were on a machine that someone touched 5 years ago who left the company that no one knows how that was installed because you didn't write the documentation, right? The familiar story. And the process of containerizing it is the documentation, to some degree, and gives you a clear path forward for the future. You already know what your application can and cannot do. And your deployment process is much closer to what you've always done, which is you're really just going to throw that container onto some sort of VM. In that regard, Docker in this case is much more like apt-get on steroids, right? Like it's a package management system more than it is a container orchestration level. So yeah, I recommend you start with something like that, and then think about how do I become cloud native? How do I use orchestration? How do I use clusters and Prometheus? And how do I monitor things? Like things get much more difficult the further you go down that rabbit hole. Yep. Anyone else? Cool. Well, thanks everyone. I'll be around. And my boss would kill me if I didn't mention we are also hiring. So basically, you guys got lots of job opportunities tonight.
Thanks, Shawn. That's awesome. Yeah, one thing we're not lacking in container land is job opportunities. So say hi to your next door neighbor, who's behind you. They're probably looking for,
Local friendly recruiter.
yeah, just to repeat that since I broke the own microphone rule. Be sure to introduce yourself to someone today. There's a lot of talented business folks and engineers here today, and hopefully Shawn will stick around a bit at the end and we can learn some more about Vault. There's a lot of that exact project going on at different companies we see here at Contino, so getting secrets right in the container space is something that a lot of engineering efforts being put towards. I'll stop talking if you're ready. I can keep talking.
I'm ready. Yeah, let me just.
I should introduce, this is Ian Sheridan, also, sorry, our next speaker. Going to tell us a little bit more about containers. Thanks for your time today, appreciate it. Looking forward to seeing how you've been using them.
Good. So I'm going to be talking about just Docker and how it should be used in automation and how automation assists in getting your Docker containers out there on your app, on your servers and things like that. So Docker in automation, instead of, it's usually when you're first learning stuff, you're doing it on your laptop. So what I'm going to be talking about is, real world ways of utilizing Docker in your applications and deployment. So Shawn hit on some of that stuff, but I'm going to go into some of the details on the tools I used and the way I did it. I might not have done it right, but it was early on in the Docker world situation. So I am a DevOps. I'm mostly an automation specialist because I come from a dev side of the DevOps scenario, and everywhere I go, I advocate, Docker and recently Kubernetes. So I'm going to be talking a little bit about Docker so that we're all on the same page. How many people actually use it in production? Because I didn't see that before. Okay, so I'll just quickly go through this. It seems like we're all pretty familiar. This is a Docker meetup. It's just so that we're on the same page. What I want to point out here is it's virtual, but it, like Shawn said earlier in his brief talk, is it instantiates an app with all its requirements, which is the best part of Docker, in my opinion. The three aspects of Docker and how this is pertinent to how we're going to be deploying it. And you need to know about the Docker file, that you're creating an image out of this Docker file, and that it's instantiated as a container. The reason we need to know these things, here's an example of a Docker file and the magic of awesomeness that it has. And the pertinent part here in when you're deploying and when you're trying to manage a real world version of this is right here. You see, this is just installing the basic Node.js. We've all probably played with Node.js or something similar to that. But the other line that we need to look at here is that this is installing a specific version of Node.js, which is always the pertinent part of what happens with managing an application that is built by developers and not yourself. Is that you have to have specific versions of things and things like that, and that's what the Docker file really does for you. So let's get out of there. And the Docker image is basically just a lightweight standalone executable package. This is your executable. What basically comes down to, and the executable, of course, is configure. You can configure it. The container is just an instantiated Docker image. And then it gets the on-the-fly configuration that you need, which is very important to when you're deploying and you're trying to, and you're feeding information into your Docker container when you're running it on a production system. And things in nature. So how do we use Docker? In a deployment pipeline, you want to integrate it into the unit testing, or not the unit testing, but the behavioral testing of the live container that you create. So how do we put it into automation? What are we doing? What are the goals that we're trying to achieve while automating Docker? We're trying to build the app, trying to build the Docker image. We're trying to, and this is one of the other key issues with deploying and managing Docker on a production system, is you have to have a location that is accessible by your orchestration. Orchestration, like Kubernetes, or just a script that lives on a server that's putting your container, your images on certain cluster of container of instances or things of that nature. And the last thing is, as I said, you want to test the instantiated container before it goes out to your systems. The reason for that is that, yes, unit testing can happen. It works, and so the app technically works, but does your configuration of the Docker image of the Docker container instantiate, does that work? Did you do it right? And you want to make sure that you're testing the instantiated container before you send it out to your systems. So what tools do I use to do this? Jenkins, Travis, Circle CI, this is the CI/CD tool set that is out there. You can do all this type of stuff with Docker, with any one of these type of CI tools. I use Bash, Ruby and Python, whatever the flavor is that I need to use on the system that I'm trying to do. What I'm trying to do when I'm scripting things on how it deploys and how we build the app and things of that nature. And depending on your orchestration layer, you'll use Bash to send it out to your Kubernetes cluster or something, deploy to your Kubernetes cluster, and you need to use either Bash, Ruby, or Python. They're all pretty agnostic. And within those Bash, Ruby, and Python, you're using your orchestration CLI tools. Like Kubernetes has kubectl and other things like that. If you have to deploy I had been in a situation where I needed to have 2 clusters up and use an AB switch. I needed to switch right away because the application needed to be warmed up. I'm sure some of you might have been familiar with that in Java land. But things had to happen before the app could actually be on the production system. So you have to use stuff like infrastructure. You have to bring up some infrastructure or new cluster, or God forbid you have a disaster recovery situation and stuff like that. So my preferred tools are Jenkins and Bash and Ruby, basically. How do I use these tools? The code base. What I try to do is make sure that which always comes handy when you're working with Docker, and you're working with a large dev team, and maybe there's fewer of you than there are of devs. For instance, I was in a situation where there was 2 of us for the whole digital arm of a company, Univision, and there was about 30 developers. So what I had to do, the way I solved that situation, and the way that is really a convenient way to do it for even a small team, is make sure that your scripts and all those things are in the code base, so that you can work with the dev team and include them on, is this the library you need for this app? Is this the way, it might, for instance, if it's Node.js, is it the right version of Node? Is it, how is the Docker file looking correctly, looking good? Is that the way it's supposed to be, supposed to be happening? And it gives you the opportunity to have an extra pair of eyes of experts on your app. And your app is not only your app, it's everybody's app. So to have it in the code base is cool. How I usually do that, and which is is I use make. Make is a great way to do this because it's basically bash, and you can execute other Ruby scripts and Python scripts. And what allows you to do is put in the base directory of your code base to allow for things like compose. So you can you can bring up what is also handy, which is, this is not really part of my talk, but when you're trying to spin up a new developer, you have it all in the code base, all the ways to instantiate it. So you use maybe Docker Compose and execute that with a make command, and bam, they're up and running. But what's also handy about make is like you can have a deploy command that deploys to help them deploy to like a developer environment, or you have a variety of different things like I don't know if any of you work with Ruby on Rails, but there's this idea of database iteration, changes and things like that. You can have commands for that and things like this. So there's a variety of reasons to use make on your app, which always come in handy, and it's really not that hard. So I mean, that is pretty much what I want to elaborate a little bit more on is the executing of scripts that are in the code base. The way I do it is actually in Jenkins. I have Jenkins execute scripts that are in a predetermined spot in the code base with a predetermined name and things of that nature. This way, I have a rudimentary, I simplify my Jenkins job, but I put all the complexity in the place where it should be, in the code base, in the repo, where you can say this, and then you can follow the same policies or same kind of workflow that your developers are following. They're doing pull requests, they're changing code, and they're updating things, and they're getting code reviews and things like that. If you put having these scripts in code base helps you tremendously in exposing what is happening with your apps and what you're doing with it, and it enables you to have a better communication with your developers, to enable them to say, hey, you're doing that wrong, or hey, we need this, or if they're compressing, CSS and front user interface type of deals. This way that all your code can be exposed, because when you have it in Jenkins, and I've spent a long time doing this, it's not exposed to your developers, or as a developer, you have a hard time. You have to get access to Jenkins and have like admin access to change the job or update a configuration for things. And when you get there, but when you expose it in the code base, they see it right away, and it's in a familiar place for them to help you out. And that's pretty much what I wanted to talk about tonight. So, any questions?
We're going to make you ask on the mic if you have questions. So, any questions on Shawn's workflow? Oh, right. Hold on. Sorry.
Hi, thanks for the great talk. I have a question about your CI tool. So in our testing flow, we're using Travis to build out to instantiate the containers and then run the tests. How do you manage the testing data in your applications? Do you have fixtures that you use, or do you have any sample databases that you pull in from an external repository?
The answer to that is a few different things. If you have, depending on what you're testing, you might be able to just use Docker Compose to bring up a small like MySQL server and have that suck in some information. That's kind of drawn out. But in general, I usually have a database specifically for testing, where that periodically pulls in production data or something like that, so that when the tests happen, it's happening against reasonably real data. RDS or whatever that circumstance is in your system is usually, I bring up a database on the side.
So for every Travis build, you would import, I mean, is it a small, is it like a completely struct database that's very small and important?
Well, that's a good point. Well, it depends on what you're testing. Are you testing speed of accessing data that's something like that, or you're just trying to make sure that your data going in and out is correct? Like if there's data transformations happening and stuff like that, you might want to have like just a local container just instantiated and just populated with some dummy data or something.
Do you have Jenkins in a master slave setup, or is it all on single node?
It depends on how big your code base is. If your code base is millions of lines, you're going to want to have a Jenkins cluster, because that's a lot of unit testing to do and a lot of code to go through. So, in those it depends on the circumstance of what you're compiling, so you can put it in a container. How big the unit test suite is, really. Did that answer your question?
Not the way I was thinking about it.
Oh,
I was
sorry.
more concerned that if you have multiple, do you have a slave spawn off every time you run a test or every time you run a build, or do you have everything run on the master itself? Like if you have multiple builds running, if you have multiple projects.
Sometimes the code base is super small and you can run it on the master, but normally I like to have a slave situation going on.
Okay.
So, I mean, it's varied, so some places have like a large code base that requires all those extra nodes and stuff.
Are you running containerized slaves, or is it VM-based?
I haven't made that leap yet,
Hmm,
because when you're with your tools, you use them as they are, and get to them last usually. Any other questions?
Let me move my way to the back.
Hi, so you mentioned you use a tool called Make.
Yeah.
So
I mean, have you ever compiled an app or a library for your development?
Yep.
So at make install, right?
Mm-hmm.
So it has a make file, and the make file, it just basically has a simple list of commands that you run on to build your app or to install it or to do. You can have it do pretty much any command you want.
Okay, so is it an official Docker tool, or is it an open source project?
No, it's not official. It's just a Linux-based, server-based type of tool that's used for making an app.
Okay.
Or compilation. Usually, that's where most people are first introduced to it.
All right, thank you.
Yeah, anywhere you see Docker files, make files are not far behind, in my experience. Any question?
Well, it was more of a comment for the guy who was talking about the Jenkins usage. So, I mean, depending on what you are, if we can do this offline too. So depending on like the size of your Jenkins file, you could have a really beefy Jenkins master and call it a day. There's also like the Jenkins slave plugin that will dynamically spin up Jenkins slaves. You could use that instead.
Yeah.
So.
Yeah, good point. Another function you can look at when deciding how to create a Jenkins farm is how many tests are you running? 10, 100, 1,000? And generally, the more tests you run, the more slaves you need. Any other questions for Ian? I think Ian and Shawn might hang around for a little bit afterwards if you want to help us finish the pizza.
No.
Question was, do you Dockerize Jenkins?
I haven't. I've played with it, but I haven't had it in production system. Yeah.
For a node-based architecture, what are the biggest issues, if any, have you seen or would you experience?
Node.js is a pain in the ass when you're trying to build it, get down all the libraries. That's usually where the big pain point happens. Other than that, I've had a pretty good experience with Node.js. But frankly, the apps that we were building were API based, so that's where it wins a lot. So, does that answer your question? That's all I have. I'm sorry.
We've also seen Node apps struggle to scale. It doesn't seem to be built for speed in terms of distributed systems, and we see people moving from Node to Golang a lot of times.
I've seen that with Docker files and dependency issues in terms of you want to distribute something and every time they do an update, not currently.
It sounds interesting.
When you have an issue with a node dependency, like an npm package, like Webpack updates another version, and then you try to run a Docker file, and I was just working with a headless WordPress architecture, and I couldn't run the files that a colleague sent me because one was depreciated and 2 just updated, and it was a pain because for some reason when you use Docker files, you have to strip it back out. It wasn't as easy as it should have been.
Sorry about that. One of the things that contribute to that problem with Node is that NPM is garbage first. So if you're using it, switch to Yarn, and just love your life much more. But the way NPM works is it's actually downloading the entire dependency tree into the folder you're working in, right? So a lot of times in your Docker file, you're going to have a line that says copy dot or whatever to copy your application in, and that's where you get this weird dependency issue. Because in your Docker file, oftentimes there's an npm install, and then you do the copy later or before, and that starts merging those two things from your local machine, which may be a Mac and not the right architecture, right? So especially when you're dealing with things that are static binaries, right? So if you've got a Node app and you got a static binary for MySQL or for FFmpeg or something like that, it'll build it on your Mac, then copy it in after it built it in your Docker container and overwrite that with the wrong architecture for a Linux build, right? So one of the things you got to be very careful about with Node especially is making sure to do that in the correct order, and to, if you can, use a Docker ignore file. Are you familiar? Yeah. Yeah, and then make sure that you're ignoring your entire npm tree. Does that make sense?
No, that makes a lot. That actually fixes the issue.
Yeah. We see that a bunch.
All right, solving production problems here at DockerNYC. Anyone else have a problem at their job? We can fix it for you? All right. Thanks, Ian. Okay, so I think we have a little extra time to socialize afterwards. Daniel, if that's okay? We could quiz our experts and talk more about NPM and Jenkins. Thanks all for coming. Appreciate it.